Okay, so this semester, our first unit is going to be on exponents. So today we're going to first talk about monomials. So the word or the root mono in monomial just means one. So that would be one term. So it says a monomial is a number, a variable, or a product of numbers and variables. So I wrote some examples here. 10 is a monomial. It's one number. X is one variable. Y is one variable. 5x is even a monomial, and I know that there are two pieces there, but because they're being multiplied, that is considered one term. So when they're attached by multiplication, that's one term. So this is a monomial. Same thing for here. This is also a monomial. So negative 2xy is a monomial because it's all attached by multiplication. So that's one single term. 12x squared would also be considered a monomial. Again, they're attached by multiplication right here, so that's 12 times x squared technically, but that's still a monomial. So monomials with the same variables and exponents are like terms. So up here, the only like terms I have are 5x and this x right here. All of these other ones would be not like terms because they have something different. So they would not be like terms. So to add or subtract monomials, just like we've been doing the whole first semester, all you do is combine like terms. You do not change the variables or the exponents. So all you're doing is combining like terms. So we're going to do some of these examples together just to show you kind of how this is going to work. Again, this should be review. We did this in the first semester. Okay, so starting with number 1, we have 17x minus 25x. So the first thing we need to know is, are they like terms? We know they are like terms because they both have a variable x. So this one has an x, this one has an x, those are like terms. So all we do is 17 minus 25. So when you do that, you get negative 8. 17 minus 25 would be negative 8. And we leave the variable exactly how it is. So this would simplify to negative 8x. And that is it. We are done. So I'm going to do the odds with you guys. So number 3, negative 15a cubed bc. That's a monomial. We can combine it with something else that has an a cubed bc, which is exactly what this is. So we have plus 6a cubed bc. So these are like terms because they have all of the same exact variables, a cubed bc. If this just said abc, those would not be like terms. It has to say a cubed bc. So we're just going to do negative 15 plus 6, so that's the same thing as 6 minus 15, or however you want to think about that. So that's going to be negative 9. So we combine the coefficients. We do what the coefficients say. So negative 15 plus 6, we leave the variables exactly like they are. So this simplifies to negative 9, and then we leave a cubed bc. And that is it. We're done with that. Number 5, we have 2ab plus 9ac. So 2ab can only be added to another ab term, and this is not an ab term. So these are not like terms. We cannot do anything with this, so we're going to leave those exactly as they are. So our answer here is the problem. So 2ab plus 9ac would be your answer there. All right, on number 7, we have 2/5 CD squared minus 1/3 CD squared. So those are like terms because they both have CD squared. So you probably want to use your calculator to do 2/5 minus 1/3. Otherwise, you're going to have to get a common denominator. So we'll actually do that just to practice. So this is like 6th grade math. So to get a common denominator, we need to figure out what both of them can multiply by to get the same number. So this one, the 2/5, can multiply by 3, and this one can multiply by 5, and then we would get a common denominator of 15. So I'm going to multiply this one by 3 over 3, and I'm going to multiply this one by 5 over 5. So this is going to be 6/15. You just multiply straight across, CD squared minus 5/15 CD squared. So we got a common denominator by multiplying to get the same number in the denominator. So now when you subtract, you just subtract the numerator but leave the denominator. So our denominator is still going to be 15. We do 6 minus 5, that would be 1, and we leave the 15 in the denominator. So it's 1/15 CD squared. Let me fix that real quick. So CD squared, 1/15 CD squared is our final answer. Again, you could just use your calculator, do 2/5 minus 1/3, you would get 1/15. I didn't have my calculator ready to do that, so. Number 9, we have 3y plus 9z plus 4y minus 3z. So this is more like what we saw in the first semester where we had like terms. So we have a 3y and a 4y. Those can go together. We have a positive 9z and a negative 3z. Those can go together also. I should have underlined this plus with the 4y. So remember to take the sign that's right in front of it. So we're going to do 3y plus 4y. So 3y plus 4y is 7y. And then we're going to do 9z minus 3z. So not this plus, because that goes with a 4. 9z minus 3z is going to be a positive 6z. All right. Number 11 is a little bit tricky for a lot of students because they see W, 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 and they think they're all like terms, but they are not. W squareds can only be added to other W squareds, and W's, like 9W, can only be combined with another W. So you're going to only put the W squareds together. So we're going to put 13W squared plus 4W squared together. So 13 plus 4 is going to be 17W squared. And then we have 9 minus 31. Those are both, they both have a W, so those are like terms. So 9 minus 31 is negative 22. So minus 22W. So definitely use your calculator. These are not numbers we would normally work with, so use your calculator. Then these are not like terms. This one's W squared, this one's W. We're done with our problem there. Right. Number 13, find the sum of 16y squared and negative 5y squared. So you need to know that the sum means to add. So sum means to add. So we're going to add 16y squared plus, let me erase that, plus negative 5y squared. So when we add when we have plus and negative, basically that's like minus. So 16 plus negative 5 would be 11, and then we leave the y squared. The only reason I was able to do that is because this one was a y squared and this one was a y squared. I didn't actually go over that. But if this had been y squared and this was just y, you could not do that. So your answer would just be 16y squared minus 5y. But in this case, they were like terms, so we could combine them. So this is our answer. And then number 15 here says subtract 9a from negative 15a. So a lot of students would mess this up just because of the minus and the negative. So we're going to subtract 9a. So 9a is actually going to be minus 9a because we're subtracting that from negative 15a. So we start with negative 15a and then we subtract 9. So when you have two negatives, you add those and keep the sign. So 15 plus 9 basically is 24, but because they're both negative, then it's negative 24. So it's going to be negative 24a. Okay, so that is a review of what we did last semester. Now we're going to look at what we are doing this semester. So we are going to start with multiplying monomials. So when we multiply monomials, we use the product rule. So again, up here, we were adding sometimes a negative, right? So subtracting, basically. We do not change the variables and exponents when we add and subtract. That is not the case when we multiply. We can always multiply them. So to multiply monomials, we use the product rule. This is on your formula chart. So the first thing is they have to have the same base, so that this one has an x and this has an x. That's important. But what we're going to do basically is you take the a and the b and you add them. So this is the same thing as x to the a plus b. Okay. All right, so let's just jump into some examples here. So 17, we have x squared times x cubed. So again, they have the same base. The x is their base. So we can do that. So x squared times x cubed. You do not multiply these, you add them. Basically, what you are multiplying are the coefficients. So in front of these is a 1 and a 1. So you would do 1 times 1, which is still just 1. We leave the x, and then we add these two together. So that would be to the 5th. Essentially, you have, I'm going to just rewrite this in expanded form. So x squared is xx, or x, times times x, because that's x cubed. So all together, you have x to the 5th, which is how we get that. So a lot of students would choose to do this, and you can do that, but when you get numbers larger than 2 and 3, it just takes a little bit more time. Okay, so let's look at number 18. So we have a to the 9th times a. So we can multiply these. We cannot add them, but we can multiply them. So to add, all we do is add the exponents. So this 1 right here has an imaginary 1. They don't write that, but there's an imaginary 1, just like there's an imaginary 1 in front of both of these as well. So we do 1 times 1, so the coefficients, the 1 in the front, 1 times 1 is still 1. We leave a, that's our only variable, and now we add these together. So 9 plus 1 would be to the 10th. 1a to the 10th. And that's our final answer. Number 19, same thing. We have w to the 7th times w to the 4th. So these are both w's. We can multiply them. So we're going to multiply the coefficients. Again, so all these examples had coefficients of 1. So 1 times 1 is still 1. We leave the w, and then we add these together. So 7 plus 4 is 11. So 1w to the 11. All right, so now we're going to look at ones where we have some coefficients. So these all had coefficients of 1, so there was no real change there. We left those as 1 because 1 times 1 is 1. So when we have coefficients, you actually multiply the coefficients and simplify the variables with the product rule. So exact same process, just now we have a coefficient in the front. So looking at number 20, so we're going to multiply coefficients. So our coefficients are 4 and 3. So imagine that x squared and that x to the 5th weren't there at all, and it just said 4 times 3. No one would question that. But when we add in variables, then we start questioning, well, what do I do now? So we multiply just like we always have. So 4 times 3 is 12. And then we leave the x because both of these are x, and all we do is add these together. So 2 plus 5 would be 7. So 12x to the 7. All right, I'm going to go down this column here. So number 23, now we have two variables. So we have negative 4a cubed b and 3a squared b to the 5th. We're not adding these, so it doesn't matter that they're not like terms. If this said plus in the middle, we could not do this, but it says to multiply, so we can do that. So just like the last one, we multiply the coefficients. So we multiply negative 4 and 3, that's going to be negative 12. And then we add the a's together. These have the same base, so that base of a, we add those together. So a cubed and a squared, 3 plus 2 would be a to the 5th. And then b, that's an imaginary 1, b to the 1 and b to the 5th. So these again have the same base, so b's go with b's. So 1 plus 5 would be b to the 6th. And that's it. So negative 12, a to the 5th, b to the 6th is how that simplifies. All right, number 26. Now we have three monomials. So we have 2y times negative 5y squared times 3y cubed. Again, if these said plus in the middle, we could not do this. But because they say multiply, we can do this. So now all we do is multiply the coefficients. So this time we're going to multiply 2 times negative 5 times 3. We're going to multiply all three of those together. So 2 times negative 5 is negative 10. Negative 10 times 3 would be negative 30. So we're going to write that as negative 30. So I'm just going to write out here what I actually did. You do not need to write this, but I want to make sure everyone understands. So we multiplied 2 times -5 times 3. So this gave us -10 times 3, which is -30. Then we take our y's. All of them are y's, so those have the same base. So y to the 1, do that in a different color, y squared and y cubed. So we're just going to add these together. So 1 plus 2 plus 3. So 1 plus 2 is 3, 3 plus 3 is 6. So y to the 6. So -30 y to the 6th is our final answer for this problem. All right. Let's do number 35. So 35, notice we have multiply here and multiply here, but we have an addition sign in the middle. For us to add this side to this side, they have to be like terms. So we're going to follow order of operations, which multiply comes first. So we're going to do that, and then we'll see if we can add. So we're just going to focus on one side at a time. So we do 2 times 4, that would be 8. Right? 8. And then we have x to the 5th and x, again, that's x to the 1. So we add those together. So that's x to the 6. Then we have y squared and y cubed. That's going to be y to the 5th. So this side simplified, so this left-hand side simplified to 8x to the 6, y to the 5th. They want us to add that to whatever this side simplifies to. If it is not x to the 6, y to the 5th, we cannot do that. So let's see if it is. So we're going to, again, multiply coefficients. So this one has an imaginary coefficient of 1. So 1 times 3 is 3. Right? 1 times 3 is 3. We have x to the 4th and x squared. So we're multiplying. So we add those together. So 4 plus 2 is 6. So x to the 6. And then we have y to the 4th and y. Again, imagine that that's a y to the 1. So y to the 4th and y to the 1. 4 plus 1 is 5. So again, for us to add these have to be like terms. And they are, because we have x to the 6, y to the 5th, x to the 6, y to the 5th. Now when we add, this is what we did on the front. When we add, we only add the coefficients. We do not change the variables and the exponents. So our x to the 6, y to the 5th is still going to be in our answer. We do not change that. So 8 plus 3 is 11, and then we leave it, x to the 6, y to the 5th, and that is your final answer. All right, so we're going to stop there, and we will go over the rest of them in class.